Hello friends, welcome back. In this tutorial, we will study about Hill Cipher. Hill Cipher is an example of polyalphabetic cipher. In Hill Cipher, plain text is divided into equal size blocks, and the blocks are encrypted one at a time in such a way that each character in the block contributes to the encryption of other characters in the block. The encryption key, the encryption key in Hill Cipher is a square matrix of size m cross m, where m is the size of the block. Now, the encryption key matrix in Hill Cipher needs to have multiplicative inverse in Z26. In Hill Cipher, a numerical equivalent is assigned to each letter. As you can see here, so numerical equivalent assigned to letter A is 0, numerical equivalent assigned to letter B is 1, and the numerical equivalent assigned to letter C is 2, and so on up to Z. Numerical equivalent assigned to letter Z is 25. Now see how the encryption takes place in Hill Cipher. First of all, consider a plain text block of m characters p1, p2, p3, so on up to pm. Now p is a row vector representing this plain text block. So here you can see that p is a row vector, and the elements of this row vector is p1, p2, p3, p4, so on up to pm. Because these p1, p2, so on up to pm, these are the m characters of plain text block. Now suppose cipher text characters corresponding to these plain text characters p1, p2, p3, so on up to pm are c1, c2, c3, so on up to cm respectively. Now suppose c is a row vector representing the cipher text block corresponding to the plain text block p. So as you can see here, c is a row vector which represents the cipher text block corresponding to the plain text block p. So the element of this row vector c is C1, C2, C3, and so on up to Cn. Now suppose the encryption key is K. So here K is a square matrix of size m cross m, because you can see that the size of block is m, right? Size of plain text block and cipher text block is m. Therefore encryption key is a square matrix of size m cross m. Now see, suppose K is the encryption key. So the matrix K is an encryption key which we are using here in this Hill Cipher. So the matrix K must have multiplicative inverse in Z26. Now suppose K inverse matrix, right? This matrix is a matrix which is representing the multiplicative inverse matrix of K in Z26. Now how the encryption takes place in Hill Cipher? Encryption takes place according to this formula. This formula you can see, we multiply p and k, and then we take mod 26, and then we will get this c, right? So what we do, we multiply this row vector p and matrix k, right? When we multiply row vector p and matrix k, right, after that we take mod 26 of each element of the result, and then what happen, whatever the result is a row vector c. So what is the row vector C? This row vector C represents the cipher text block corresponding to the plain text block P. It will be more clear when we do an example of encryption and decryption in this tutorial. Now how the decryption takes place. For decryption, we will use this matrix K inverse. So what is the K inverse? K inverse matrix is the multiplicative inverse of K matrix in Z26. So to get a plain text from cipher text in decryption process, what we will do? We multiply C, row vector C, and matrix K inverse, and then we take mod 26 of each element of the result, and whatever the result we get finally, that is the plain that is a row vector, and which represents the plain text block P. So in this way we can get the plain text block from cipher text block. This is how the decryption process takes place in Hill Cipher. Since K inverse matrix is the multiplicative inverse of matrix K in Z26, therefore K into K inverse mod 26 is equal to I, where I is an identity matrix. It will be more clear after this example. Suppose we are having this plain text, code is ready. Now let us see how the encryption and decryption will take place in Hill Cipher. So suppose here we are dividing this plain text into a blocks of size 4, right? So here the plain text block and cipher text block will be of size 4. So here we have divided this plain text into the size of 4 characters. So first block has these 4 characters C, O, D, E. second plain text block is having these 4 characters ISRE, but the third block is having only 3 characters, right? So you can see that here 3 blocks are formed and the last block has only 3 characters. So we will add an extra bogus character Z to the last block, so that last block will also have 4 characters, right? So what we have done here, first of all, the plain text is divided into the blocks of size 4 characters. Now let us see how the encryption of these blocks will take place. So first of all, we will see the encryption of first block, which is having only these characters CODE. So you can see, as I told you earlier in this tutorial, that a numerical equivalent is assigned to each character. So the numerical value equivalent to C is 2, and the numerical value equivalent to O is 14, and the numerical value equivalent to T is 3, and for E it is 4, right? So here you can see that this plain text block, which consists of these 4 characters CODE, right? So this is represented by this row vector P, right? And its elements are 2, 14, 3 and 4, right? So 2, 14, 3 and 4, what are they? They are the numerical values equivalent to these characters CODE. Now suppose encryption key matrix K is this one, right? So how we will get ciphertext block C? So we need a ciphertext block C. So how we will get? The formula is P K mod 26, right? We will use this formula. We will multiply this row vector, which represents the plain text block, encryption key K, and then we take mod 26 of each element of the result. Then after that we will get this row vector, right? And this row vector represents the ciphertext block corresponding to this plain text block. Now you can see here the elements of this row vector are 14, 7, 10 and 3. So this numeric value 14, this is equivalent to character O. This value 7, this is equivalent to character H, and this value 10, it is equivalent to character 7. This value 13 is equivalent to character N. So the ciphertext block corresponding to the plain text block CODE is this one. You can see here OHKN, right? So ciphertext block for plain text block code is OHKN. CODE code was the plain text block, and ciphertext block equivalent to it is OHKN. So this is how the encryption takes place. Now how the decryption takes place in Hill cipher. So in this example, what we need K inverse matrix. We need the multiplication inverse of K matrix in Z26. So suppose this is the K inverse matrix, right? This is the multiplicative inverse of K matrix in Z26, right? So what we will do to get the plain text block from the ciphertext block, what we will do? We will multiply ciphertext block with this K inverse matrix, and then we will take mod 26 of each element, right? We will use this formula P is equal to C K inverse mod 26. So when we performed this computation, we got this row vector. So this row vector is a P vector, right? This is the P row vector, which represents the plain text block, right? So you can see that numerical value 2, right, it was assigned to character C, right? And numerical value 14, it was equivalent to O, right? So similarly, what will happen? We get this plain text block CODE, right? So this is how the encryption and decryption takes place in Hill cipher.